I'm Anil Kumar. Welcome to my website, globalmathinstitute.com. In this video, we'll learn about linear equations and its applications. I've summarized many formulas which are based on linear equations, and this video is very helpful for students who are competing in different types of competitions and exams. In case you need help, you can always contact me on the address given here. These are the formulas which are related to lines. Some of them are very familiar with you, and some we don't really apply so many times. However, in competitions, you may see some questions based on these formulas, and that can make a huge difference in your selection or achievement. So let's go through these formulas, and then we'll have about 10 examples where we are going to apply these formulas and see how to work with them. The very first one is slope-intercept form of a line. Y equals to mx plus b, commonly used most of the time. Whenever you want to find equation of the line, you find the slope between the 2 points by finding change in the y values divided by the change in the x values, right? So we say m is equals to y2 minus y1 over x2 minus x1. Now this equation of the line you can also find using the intercepts. So if you have a graph of a line, for example, if this is the line, in that case, we're talking about the x and y intercepts. So let us say A is the x-intercept, B is the y-intercept. Then you can directly write down the formula as x over A plus y over B equals to 1. It's a very effective way of getting the equation of the line. So many times you might also see this formula written in slightly different ways. So let me rewrite that. We could also say if we cross multiply with AB, I could write this as BX plus AY equals to AB. You see that? So when written in this form, you can actually divide by AB as shown here, find the x and y intercepts, right? Point slope form is used many times where we are given slope and a point x1 y1, and here it is. A simple derivation of this is basically rearrangement of the slope form, right? So if you rearrange this formula, that is to say cross multiply, then you get that formula. Let's see how. For example, we just wrote m equals to y2 minus y1. Let me just write difference of y values as kind of like this, right? So two y values, x1 minus x. When you cross multiply, what do you get? Well, you get m times x1 minus x is equal to y1 minus y. Is that clear to you? So difference in y values is equal to product of slope with the difference in x values. So that is rearrangement of the slope form. So we call it point slope form. And then the length of the segment given 2 points, that is the standard formula, x2 minus x1 whole square plus y2 minus y1 whole square. Now these are some formulas which are not commonly used. Now the formula here is distance from a point to a line. It really means that if I have a line, right? So in that case, so that is my line, and if I want a distance from any particular point to this line, we'll have to draw a perpendicular on this line, and then we can find the distance. Let us say the coordinates of these points are x1, y1, and the equation of the given line is ax plus by plus c equals to 0. In that case, the distance, let us say this distance is d, will be given by the formula given here. So you basically substitute the coordinates x and y, these x1, y1, into this equation, correct, which is the numerator, and then divide by the absolute value of, the the distance is always positive, they divide by square root of a square plus b square. Now you have to take the absolute value of the numerator, right? Denominator is always positive. Correct. Many students who've done vectors will also recall this as a equation given in the standard form, right? Cartesian form of the equation, and this formula being used there. Now, in this particular formula, there could be special cases. You might be in a position to find the distance from the origin, right? So if you have to find distance from the origin, in that case, x1 and y1 will be 0, right? So you get c in the numerator. So that is another interesting thing to see. That is to say, when you have something like this, let me just sketch a line which is going like that, and you are interested in finding the distance from the origin, right? So this is from the origin. In that case, the distance d will be equal to c over square root of a square plus b square, right? Since x1, y1 values will be 0, so the first two terms will be 0, so you get that as the constant c, right? Okay. Now, this distance formula can also be used to find distance between two lines. For example, two parallel lines. So if I have another line here, for example, then the difference of these two c values will give you the distance between these two lines, correct? So here you can see that the difference between these two values is basically difference between the two c values, and that makes sense. So these formulas can be derived from one another, correct? Now, there is very important formula based on the segment being divided into a ratio of m is to n. We also call these formula a section formula. Correct? So, if you're dividing a segment in the ratio of m is to n, that is to say that if I have this particular segment, let's call this value as a, this value as b, and let's take a point in between, let's say P. And we are dividing this in the ratio of, let's say, m is to n. In that case, where the coordinates of A is x1, y1, coordinates of B is x2, y2. Okay, in that case, the formula is that the x value will be m times x2 plus n times x1 divided by the sum of m and n. And similarly, the y coordinate value will be m times y2 plus n times y1 divided by m plus n. Very useful formula, section formula known as OR. When you divide a segment in the ratio of m is to n, that is how you can get. Now, the last formula which we'll discuss here is about the area of a triangle, given 3 points, of course. So 3 vertices of the triangle are given to us. Let us say, let me make one triangle here, right? Let's say that is any general triangle, in which case we have the 3 coordinates, which is, let's say, x1, y1, x2, y2, and x3, y3. In that case, the area of this particular triangle can be given by the formula half of x1 times y2 minus y3 plus y2 times x2 times y3 minus y1 plus x3 times y1 minus y2. You should remember that this goes in a cycle, right? So basically, you could say in a cyclic order, we have written the numbers, right? 1, 2, 3, then again 2, 3, 1. So 2, 3, 1, and then 3, 1, 2, 3, 1, 2, right? So it is in this particular order when we are writing x and changing y, and that helps. And there are many different ways, shortcuts to also calculate this value, which you can look into your literature or some of my videos. So that gives you overview of what kind of examples we are going to take. These are the best examples which you will find anywhere. Okay, we'll begin with very simple case and take example number 1, which in this case is regarding slope and intercept form of the line equation. The question here is, an airplane flying at an altitude of 1.8 kilometers begins to descend. It follows a straight line path to land at a horizontal distance of 3.6 kilometers. So here we have shown the altitude, right? We have taken it along the y-axis, and the plane is descending, lands 33.6 kilometers away horizontally as shown here, correct? That is the situation. Now, based on this, we have a question which is, consider the height of the plane from the ground along the y-axis and the horizontal distance on the ground along the x-axis. Now, even if I don't write this, this is what you should be considering while solving such questions, right? Now, the question is, determine the equation to represent the path of the airplane. So we have to basically provide the equation of this particular line. So that is the equation for you. Now, as we discussed many different formulas, you could adopt any one of those formulas. Intercept form is probably the best, but we'll begin with slope and intercept form, correct? So in this case, we know the y-intercept is given to us, which is 1.8. The x-intercept is 3.6. We can definitely find slope from here. So we'll use the slope and intercept form of the equation y equals to mx plus b, which generally most of students will be doing. The slope over here you can see is negative for sure since the line is falling. Y2 minus y1 divided by x2 minus x1 will give us the slope. Substituting these values, we can find that the slope is negative half. Now, writing negative half for m, x plus b we know is 1.8. And so we have the equation. It could be written in standard form or the form in which we need. There's a multiple choice question, correct? So we can now match which option is same as our result. And the option clearly is B. So that is how you could get the answer of this particular question. So I hope that really helps. Well, there is always a shortcut when you're given multiple choice questions, and that is we know the points, right? You can check which point is satisfying which equation. And that ways you could easily come out with the result, right? So the shortcut here is substitute x equals to 0 in this equation and check for y equals to 1.8. So when you substitute x equals to 0, you get a negative value of y here, 1.8, but in this case, you get a positive value of 1.8. That is your answer. So that was a shortcut way of doing it when a multiple choice question is given to you. Perfect, but that is the standard method of doing it. Now let's take another example, which is example 2, very similar to the one which we took last time. The only idea here is to use a different formula. Okay, so we'll again use the same condition. However, the intercept form of the line equation will be used this time. The question now is, an airplane flying at an altitude of 1800 meters begin to descend. It follows a straight line path to land at a horizontal distance of 3200 meters. Consider the height of the plane from the ground along the y-axis and the horizontal distance on the ground along the x-axis. Determine the equation to represent the path of the airplane. So exactly similar situation. Well, some values have changed. We're taking the value a as 0, 1800. That is the y-intercept. The x-intercept being at 3200. Now, these are the two intercepts. We could directly apply the formula, which is x over a plus y over b equals to 1. Substituting the x-intercept as 3200, y-intercept at 1800, we directly get our equation, correct? We don't even have to find the slope in this case, right? That's the beauty. Now we just simplified it a bit and wrote it in the form shown here, since the choices given to us was similar to this. And clearly from here, choice A is one which is similar. So we'll mark that as our answer. Again, if you are working on a multiple choice test paper, which is sometimes there in competitions, in that case, you could substitute x equals to 0 and check for the y-intercept. So whichever gives you the right answer is the right answer. So in this particular case, as you can see, if I substitute 0 for a, in that case, y will be 9 times 200, which is 1800. And therefore, that is my answer. So you could always apply the shortcut method for such questions. Here is example 3, which is again a similar situation. We are Now considering an airplane flying at an altitude of 1800 meters begins to descend. It follows a straight line path to land. Horizontal distance is 3200. Okay, find the approximate height of the plane at the horizontal distance of 1000 meters from the landing point. Slightly different, same condition. So from 1000 meters, what is the height of the plane? That is the question this time. Four choices are given to you. The choices have units as kilometers. So it's a good idea to think about converting the units to kilometers. You get the thing, right? So you could do that. Well, here we have the situation just as we began last time. So we got the same equation which we had last time, which could be written in this fashion. Multiplying both all the terms by 9 times 16, correct? So if you multiply everything by 9 times 16, then you can get rid of the fractions and get the result as shown here. Now, the question here is, what is the height at a horizontal distance of 1000 meters? So you could actually substitute 1000 for x, right? And when you do substitute 1000 for x, you can actually find, okay, now 1000 meters, it is saying, find the approximate height of the plane at a horizontal distance of 1000 meters from the landing point, right? So it's kind of important to understand from the landing point. So the situation really is kind of like this. Now this point here is, I'm writing 3.2. 1000 meters is from the landing point. That is 1000 meters. You get my point. That distance is 1000 meters, okay? So this distance will be what? It will be 2.2. The x value is actually 2.2, and therefore 2.2 kilometers or 2200 has been substituted to find the y value. At this moment, the height is around 560 meters, right? You could do like this. But see, in this particular case, we could actually solve this question with the help of ratios concept, right? So here is a diagram for you to understand. That is the place where the plane lands. That is where it is landing. So at this point, 1.8 kilometers is the height of the plane, right? So we are using the units kilometers here, both sides. Now, clearly, now that is the one unit, and so this is two similar triangles. Do you see that? So we have two similar triangles. Now, because the ratios of similar triangles are always constant, h over 1 is same as 1.8 over 3.2. Is that clear to you? So many times you may not even have to find the equation of the line. So you could directly get the answer as shown here in two steps. So that is the beauty. So this is also the shortcut to solve such questions. So in a question, if the equation of the line was not required and you only wanted to know the height at a particular point, you could use similar triangles also. I hope that makes sense. It's a great tip. Example 4. Now in this we are going to use the distance formula. The question here is, point A, which is 0, 2, is equidistant from point B, K5, and C, 3K. Find the length of segment AB, right? So though that is the kind of question which we have. So let us say the point A is, so we can actually draw a situation here. From one point, we are trying to find the distance to the other 2 points, and which is given to us as same, right? So we don't know what exactly those points are, but we know that the distances are same. That is the situation, correct? So definitely we are going to apply the distance formula, which is square root of x2 minus x1 whole square plus y2 minus y1 whole square. Now when the distances are same, in that case square of the distance will also be same, right? So we do not really have to calculate the square root value. Correct. Now let us first find the value of k, which is given to us uh, from this particular formula. We substitute the values. So a to b, now a to b is k minus 0 whole square plus 5 minus 2 whole square. And now from b to a to c is the other distance, calculating ac, on the right hand side. You get an equation from where you can find the value of k. The value of k is 1 in this particular case, right? So you simplify 4k equals to 4, k equals to 1. Perfect. Once you get the value of k, you get the coordinate points b and c also. Correct? Once you get b and c, you can find the distance between AB or AC. So I found the distance between A to B and it came out to be square root of 10. So that is how we could do it. So I hope you understand it is a two-step question where first you have to find the coordinate points B and C and then the distance, correct? Here is example number 5, which is again based on distance, and the question here is point A, xy, is equidistant from point B and C, similar to previous situation, but the question is twisted. Find the value of y minus x. So we don't really have to find any coordinates in this particular case, but we need to find the value of y minus x, right? You could find the coordinates and then find y minus x also. Correct. Now, since we are given again that the distances are same, we'll work in the similar fashion. Square of the distances will be calculated. So here is how we do square of the distance: x2 minus x1 whole square plus y2 minus y1 whole square. In this case, we are using a to c. So you can say x3 minus x1 whole square plus y3 minus y1 whole square. And you get to equate them. When you equate them, the square terms will cancel, as you can clearly see, right? As happened last time also, these square terms will actually get cancelled. So once you cancel the square terms, you are left with the linear terms and solve the linear equation. In this particular case, you also notice that y minus x could be directly found. You don't really have to find the value of y and the value of x, right? You can actually directly get the answer as we got it here. It matches with option B, and therefore option B is the right option. Correct? So we are almost midway. Now we will land into different kinds of questions which will be slightly more trickier. Example 6 here is based on the collinear points. So we are given 3 points. The question is, the point A, B, and C are collinear. Now find the value of x. So this value of x is not known to us, the coordinate point A, which we need to find. However, we are given that these points are collinear. Collinear means they are on the same line, correct? So basically, we are given that they are on the same line. So if they are on the same line, in that case, it is very clear that the slope will be same, correct? So m is same for both, right? That is what we are saying, slope is same. So slope between A and B should be equal to slope between A and C. So we'll find the slope between A and B, and we'll find slope between A and C, and we can equate them and get the value of x. So that is what has been done. Slope, as you know, is y2 minus y1 divided by x2 minus x1. Substitute the values to find the slope of AB. Also, for slope of AC, equate them. There is only one unknown, x, and calculate that x value, which you get as 1, and therefore option 1 is the right option. Perfect. So that is how you could do using the slope. Here is an alternate method which I don't want to apply here. It is too much. Most of the time we also use an alternate method, which is basically to find the area of the triangle, right? So I'll give you the concept: area of triangle equals to 0 for collinear points, right? So you could use the area formula which we have right in the front formula sheet and equate that to 0 to find this particular answer. Here is example 7, which is find the ratio in which the point P, which is minus 1y, lying on a line segment joining the points A, which is minus 310, and B, which is 6 minus 8, divides it, right? So we have a line here. We need to figure out the coordinates of point P. So the situation is that we are given a line which is kind of dropping. We have the two endpoints which can be written as A and B. Let's say A here is minus 310 and B is 6 minus 8. Find the ratio in which the point minus 1 by some point p is given to us. We want to find this ratio m is to n. Now, many times instead of m and n, we can use a value k and 1. So it simplifies the calculation. You get the idea, right? So in that case, the total length will be k plus 1. So we'll again use the formula, which is called the section formula given right in the beginning. You should know this formula, right? Now, we're assuming that the point P is dividing the segment in the ratio of k is to 1. Then the formula changes to, instead of m we have k, and instead of n we have 1. So it is a much simpler formula to apply now. We know the values of x1, y1, and x2, y2. We can substitute these values in the formula, and we also know that the x value is minus 1. So why not only work with the x coordinate? Right. So since we have to find x coordinate, so only work with the x coordinate. Right. So we just took the x coordinate value, which is kx2 plus x1 divided by k plus 1, substituted what is known to us. We have found the value of k. You get the idea. The known thing is minus 1, the x coordinate value. So that gives us the value of the k, and k is 2 over 7. So that really means k is 2 over 7 means this is 2 and that is 7. You get the idea. So that is how we could actually find the answer, and it matches with option B, which is the right answer in this particular case. Perfect. Now, example 8, which says determine the ratio in which the line 3x plus y minus 9 equals to 0 divides the segment joining the 2 points. Now, instead of a point, we have a line. You see a variation into the same type of question. Now, how do we do such a question? Now, again, the concept here is that the point lies on the line. You get the idea. So the idea here is to remember that point P lies on the line given to us, right? Which is 3x plus y minus 9 equals to 0. This is kind of important to understand. Okay, so let's begin with the solution, which is we have to have the intersection of the line segment with the line. And let us say the ratio is k is to 1. So more effectively, this formula is used with the ratio of k is to 1, and then it is better. So if it is k is to 1, then the coordinates will be 2k plus 1 over k plus 1 and 7k plus 3 over k plus 1. So those becomes the coordinates since the points A and B are given to us. Now we can substitute these coordinates for x and y values in the equation of the line. Since the point also lies on the line, right? We have only one variable here, which is k, which can be found using cross multiplication. We multiplied each term by k plus 1 and then solved for k, which comes to be 3 over 4. So 3 is to 4 is the right answer, and that is how it should be done. I'd like you to go through this once again, understand all these steps. You can actually pause the video and then understand how to do it, right? And once you've done all these questions, you should again try on your own how to solve them. Last two questions, which is again a question based on distance this time. So we have already considered two examples based on the section formula, right? So we have these questions based on the formula, which is also known as section formula, where we talk about the division of line segment. Now we are moving on to the next set where we are focusing on distance, right? So now we are just focusing on distance of from a line or a point, right? So we'll say distance from a line, or we can say a point, right? Right. So the question here is, find the equation of line perpendicular to line 2x minus y plus 6 equals to 0, which is 7 units away from origin. So that is the question for you. Okay, correct. So in this particular case, how do we solve the question? First part is to find the equation of a line perpendicular. When I say perpendicular, that means what? So if the line is perpendicular, then the two slopes, m1 and m2, if you multiply, they will be -1 when you multiply. Or you can say the slopes are negative reciprocal, right? So one approach here is, of course, you could write this equation as 2x minus y plus 6 equals to 0. We can say y equals to 2x plus 6, right? Taking y to the other side. So we know this slope is 2. So that means the perpendicular slope will be negative half, right? And then the equation of the perpendicular will be negative half x plus b. And to find the value, this is how you could write it, right? That is one way of doing it. So clearly, if I multiply by 2, you get 2y, and this is equals to minus x plus 2b, right? So we can rearrange and write this as x, bringing x to this side plus 2y, right? And then we have that minus 2b also in this side equals to 0. Now minus 2b is a constant. More important here is that see how the x and y values interchange. So if you compare with 2x minus y, what is happening for a perpendicular line? So basically you notice that these values swap. You understand? So basically they swap with a negative sign. Swap with negative. Do you understand? So you can swap. So 2 and y minus 1 are the coefficients of x and y. So we have swapped them and wrote them as x plus 2y. Do you see that? Plus some constant c equals to 0. Directly we get the perpendicular line equation. We do not have to do all that. You get my point? If you want, you can definitely do, but it's not required. But you can always note that the slopes of these two lines which we are talking about, their product is -1, right? Okay, so the first step is to write down the possible equation of a perpendicular line, and second step is to find the value of c. The value of c can be found since we know that the distance from the origin is 7 units, right? Now, getting back to our formula, we have learned that if the line is ax plus by plus c, in that case, the distance from any point x1, y1 can be given by the formula here. Distance is always positive, so therefore, take the absolute value. Now, from origin, that means x1, y1 are 0, 0. So these two values become 0. So we have a point which is origin, which is 0, 0. And in this formula, since that is the equation, we have a value of 1, b value of 2, c as lowercase c, and the distance is given to us as 7 units. Substituting 7 for the distance given to us, c over a square plus b square square root, we get the value of c as positive and negative, 7 square root 5. Right? Why? Because if we are taking the absolute value, we could choose any one of them. Does make sense to you? So that is what is meant. Slope of this perpendicular is negative half. If you sketch these lines, I mean, what I'm trying to say here is that the line could be either on this side or on the other side, right? Both lines could have a distance which is 7 units. Do you get the idea, right? So it could be any of these lines. So that's why we have these two equations as the solution, and so both are correct options. So we have two answers in this case, option C and D. Perfect. That is how we could actually calculate. You also note here that if you're finding the distance from the origin, in that case the formula simplifies to the value of C, the absolute value of C divided by a square plus b square. The last example which I have taken here is based on the area of a triangle. So what we did was we took a quadrilateral. So in a quadrilateral we divided that into two triangles. So and apply the formula. The question here is find area of quadrilateral with the vertices given to you, right? So basically we have two triangles here. So as you can see in the solution, we are saying that the area of the triangle is equals to, let us say this is triangle 1 and this is triangle 2. So we'll have area of the triangle A1 plus area of the triangle A2, right? So that will give us the area of the quadrilateral. We applied the given formula, which is half of x1 times y2 minus y3 plus x2 times y3 minus y1 plus x3 times y1 minus y2. We'll apply this twice, one with the coordinate points A, B, C, and second time with the coordinate points A, D, C as shown here, and calculate the values. Remember to take only positive values of the result. Since the area is always positive, add them up. You get the answer as 80 units square, which is option D for us in this particular case. So that is how we'll do this question. Remember, that is the formula for area. So that brings us to the end of this particular video. However, we have gone through all the formulas which we discussed in the very beginning. I hope their application is very clear. Feel free to write your comments, share your views, and in case you need any help, you can always write to me on the email address given to you. Thanks for your time and all the best.